Hello everyone. In this class, we'll discuss about the motion of different types of motion of the follower. So we have four types of motion. So uniform velocity, then we have simple harmonic motion, uniform acceleration and retardation, and cycloidal motion. Okay, so these are the four different types of motion of the followers are available. Now to look at the first type of motion, that is uniform velocity. Okay, so in uniform velocity, we need to draw the displacement diagram. So to plot the displacement diagram, on y-axis we can plot stroke or lift of the follower. On x-axis we can plot the angle of rotation, or you can say theta, that cam rotations we need to plot on x-axis. Okay, now so if follower is moving with uniform velocity, okay, so what we have angle of rise, we have dwell, and we have return. So during angle of rise, wall loop will start. During dwell, the displacement of follower remains same, that is constant. And during return, the displacement will going to reduce, that is wall closing will start. So these are the different types of uh, motions we have, that is orientations of cam with angle of rise, dwell, and return. Now to create this displacement diagram with uniform speed, what data we need to consider? We need to take that value of theta. So while considering that theta, we need to assume suitable scale. Okay, so we will plot angle of rise, then dwell and return. Then we'll divide that rise into equal parts. Then we'll divide that return into again equal parts. Okay, and simply we can connect the diagonal points to create that uniform speed. Okay, so just connect the diagonal points. So diagonal points from first point 0 location to final. So we have A, B, C, D, E, F point. Again, second for return from point G to point M, we have this G, H, I, J, K, L, M points. So these are the representation of that particular displacement diagram, where we are plotting the values of lift and rotation. So for theta, let's say 10 degree, we have 1A displacement. For 20 degree, we have 2B lift. For 30 degree, we have 3C lift. For 40 degree, we have 4D lift. So these are the values of lift of follower we can determine, and same values you need to mark on cam control. So just look at the arrangement. Suppose we have this statement of cam knife edge follower is given. Cam is used to operate with following motion, and we have angle of stroke. So outward stroke is given 60 degree. Dwell is given 30 degree. Then we have return stroke 60, and remaining angle is 210. That is angle of dwell. The stroke of follower is given 40 mm. That is lift, and minimum radius of cam is given 50 mm. The followers moves with uniform speed, both outstroke and return stroke direction, and we have to draw the cam profile. When cam rotates in clockwise direction, the axis of follower is when the follower is given inline follower, the axis of follower passes through the axis of camshaft. And second case is given axis of follower is offset by 20 mm from the axis of camshaft. So these are the two details we have. So first we'll plot the displacement diagram. While plotting displacement diagram, we'll take scale. 1 centimeter is equal to 10 degree. So we have this 60 degree line, that is 6 centimeter line. For 30 degree, we have 3 centimeter line. Again, for 60 degree, we have this line of, just I will draw this point. Okay, so this line is of 6 centimeter. This line we have 3 centimeter, and for remaining orientation, again we have line of 6 centimeter. So these three lines we need to draw. Then after drawing this, we have to just connect diagonal points. So we have this point A, B, C, D, E, F, G, H, I, J, K, L, M, and P. Okay, remaining angle is 210 because total cam rotation is 360 degree. That's why we have 60 plus 30, 90 plus 60, 150, 150 plus 210. That total addition is 360 degree. So on y-axis, we are plotting lift of follower. Okay, so this is the lift of follower that we are plotting on y-axis, and on theta, we are plotting cam rotation, that is theta value we are plotting on x-axis. Okay, now next part is, so what we have after creating all this, I will erase this part. Okay, we just erasing this part. Okay, so what we have next, so we are again drawing the cam radius 50 mm. So radius of cam is available 50 mm. Then we are dividing this first part into 6 equal division. Dwell as it is, a remaining part into 6 equal division. Okay. So just look at that 1A displacement, 0, 1B displacement, 2C displacement. These values, whatever values are there for point number 1, 2, 3, 4, that value we need to cut on that inclined line. just will mark that values, and simply we will pass on we'll connect all these points. Okay, so if you look at the displacement of G and H, okay, so G and H is having maximum displacement. What is our maximum displacement value? 40 mm. So we can mark that 40 mm distance with respect to line number 6 and line number that 0 dash H. Okay, so for 6 and this G and H, displacement is 40. And for remaining, again, displacement is going to reduce. So for I, J, K, L, M, and for all these points, we are locating the displacement values, that is lift of follower. Okay, and after locating all these points, simply we need to create one freehand curve. That is, we need to connect simply all these points so that we will get cam contour, and remaining angle is the dual angle. So dual angle is 210 degree. Okay, so this is the all about orientation of that cam profile with angle of rise 60 degree, dual 30, and return is 60 degree. So this is the inline follower. Okay, now second part is given, offset follower is given. Now for offset follower, again we need to draw one circle with radius of 50 mm. Okay, and second circle with radius of 20 mm. Now for second circle, we'll draw one tangential line. Okay, and here we need to represent the cam orientation. Now with respect to these orientations, we'll take this as a reference line. So we'll take that point O and A. Suppose say O is the center and A is the starting point. So OA will be the reference line. Okay, with respect to that OA reference line, we need to mark all these angles. So first angle is our 60 degree angle. So again, divide that 60 degree into 6 parts, 1, 2, 3, 4, 5, 6. Again 30 as it is. Again 60 degree into 6 parts, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Okay, and we have to draw tangential line at each point. Okay, so we'll draw tangential line at point 1. Okay, so this is the first tangential line. So tangential to circle for point number 2, again draw tangential line. For point number 3, tangential line. For point number 4, point number 5, point number 6. For point number, again 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. All these tangential lines we need to draw. And above that roller circle, you can say that base circle. Okay, or above that base circle, you need to locate the displacement values like point B, point C, point D, point E, F, G, point H, then I, point J, point K, point L, M, N. Okay, and last will be the closing point. Okay, so we are drawing tangential line at each and every point, and on that tangential lines, we need to represent this lift of follower, that is displacement values. Okay, so this displacement values we need to mark on the tangential lines, and then we need to draw freehand curve. So connect all these points. So starting with point A, so we'll draw a freehand curve which will pass through all these points. Okay, and finally that curve will close at point 6 dash. Okay, so again we have 60 degree moment, that is 60 degree angle of turn. Okay, that is angle of rise. Okay, 30 angle of dwell we have, and again for 60 degree we have angle of return, and finally remaining angle will be the angle of dwell. That angle is 210 degree angle. Okay, it is angle of dwell. So in this way we can draw inline and offset follower with uniform speed. Okay, so only one thing you need to remember, whenever we are creating such type of problem statement, just try to understand whether the orientation of follower is given with respect to inline or offset. If offset is given, then we have to draw offset circle, and with respect to this offset circle, we need to mark all these angles. Okay, so this is the difference between inline follower and offset follower in uniform speed. Okay, so we stop here. In next class we'll discuss different second displacement motion, that is the second type of motion for follower. Okay.